So for our Pascal's triangle, we got to go to which row? Forward, right? So remember, here's how we start with the three ones there, right? And then I start with one. How do I get the next number? One plus one, and then end with a one, right? And I start with one again, and one plus two, two plus one. I kind of started too close to the edge here, so it doesn't look very nice, but you guys got it. All right, and then I start with one again. Then I go one plus three, three plus three, three plus one, and end with a one. So there's my fourth row, right? Remember, this top row, this single one, is row zero. The way I think about it, the row with 1, 2 is row 2. The row with 1, 3 is row 3. The row with 1, 4 is row 4. That's how I think about it, okay? So we have to use these 5 numbers to do this problem, okay? So I'll do my 1 and 2 sets of parentheses and my 4 and my 6, and then I'll just continue down here. It's always plus in between, and then our 1. Okay? Any problems so far? This thing needs unplugged and replugged. All right. So what goes in the first set of parentheses? The 5y, right? In every one of them. And what goes in the second parenthesis? The -2. So this one's going to have some minus signs in it. Okay? Now, since that's a 4, what's our first exponent for the first parenthesis? 4. And then we go down for the first parenthesis by ones, right? So that's a 3, that's a 2, that's a 1, and then the last one is 0. And then the second parenthesis always starts at 0. Good. And goes up by 1. And if you add the pair of exponents, what will they always add up to? 4, whatever the original exponent was. Okay? So that's the setup. Now I just find those answers. But I do something first before I start finding those answers. What do I do? Right, get rid of those 0 ones. Because anything to the 0 power is 1. So it's like multiplying by 1, so I don't really need to worry about it. Okay? So I just cross those out just to remind myself I don't have to worry about that part of those terms. Okay? So I just go to my calculator. Okay? I think this is the easiest thing to do. Okay? And you can't put the variables in, but you can put the numbers in, the calculator, right? So just do I need to put the 1 in? No. But if you want, that's okay. All right? You know, if you want to put 1 parenthesis, whoops, not 5 yet. 1 parenthesis 5 to the 4th, that's 625. Okay? That's your coefficient for your answer. And then it's y to the what? 4. Whatever that exponent is. Okay? Then in the next one, I could put 4 parenthesis 5 caret 3 parenthesis -2. All right? And and then just hit enter. So that's negative 1,000. Y to the what? So there's where that negative came from. And this is what's always going to happen. When you have a minus sign in your binomial, it's going to be a positive, negative, positive, negative. It's always going to alternate. Okay? When it's a plus sign in your binomial, it's always addition. Okay? So questions on how I got 1,000? All right. So here, let me show you something. You can, for some of you, it might be just a fast, just as fast to just plug it in, or if you want, you can hit second enter, and that'll bring up what you just did, and you just got to change, you guys can hold your cursor down, do that, but I got to change the 4 to a 6. I already got the 5, right? I got to change the third power to the second. I already got the negative 2, and then I got to raise it to the second power, right? So that's a 600. Y what? Squared, right? Because my y is squared there. Then I can go back to my calculator, hit second enter, and change this to a 3 this time, right? And squared to a 1, right? And then the 6 changes back to that 4. And I get negative 160. For this one, there's that negative again. Y to what power? First power, right? You don't have to put the 1, but if you do, it's okay. And then the last one, I would just put negative. I wouldn't redo all that. You just need negative 2 to the 4. Which you guys should know is positive 16, right? You don't even need the calculator really for that one. Okay? So if you were having problems getting that 625 and that negative 1,000 and that 600, I would use the calculator. You don't use the variables. You just look at the variables, see what their exponents are. That make sense? Okay, so that's what we were doing last night. All right, so here's your homework. All right, does anybody need me to go over one of these after you looked at the answers that I gave you? Are we okay though? Or are we okay? No questions? AJ, is it making any sense? I know it's your first day back. Spencer? Landry? We're good? All right, so that really isn't too bad once you get into practicing a few. You guys have been absent for a few days. If you practice those a little bit, I think you'll be okay. All right, so today we're going to do, so we've done polynomials, that's what we're working on, right? We've done addition, subtraction, multiplication. We expanded these binomials yesterday. Now we're going to do division, okay? Today we're going to do long division. All right? All right, polynomial long division is a method for dividing a polynomial by another polynomial of a lower degree. It's very similar to dividing numbers. Okay? So, when I divide numbers, okay, I ask myself, how many times does 3 go into 4? You guys know it's 1. So I put a 1 up there. Then what do? I go 1 times 3, right? And then do what, Cole? Subtract. I get a 1. Then what? Bring the 3 down, right? Then I ask myself, how many times does 3 go into 13? We say 4. That goes up here. Then I go 4 times 3 again, and then subtract again. I get 1. Then I bring down the 5, and then I go, how many times does 3 go into 15? 5. So 5 times 3 is 15, so I have no remainder, right? You guys know how to do long division, right? All right, well then you better watch again. Here, I ask myself, how many times does 12 go into 2? Doesn't. So then I ask myself, 12 goes into 27 how many times? Twice. So I put a 2 up here. 2 times 12. Subtract. Bring down the 7. How many times does 12 go into 37? 3. 3 times 12? Subtract 1. So we put our remainder like that, right? You might have put an R1, but when we do these polynomials, we're going to put plus or minus, depending on what it is. And then we're going to put whatever it is over whatever we divided by. Okay, the divisor. This is called the dividend. The 277, the 12 is the divisor, and the answer is the quotient. All right. So we're not going to do those. We're going to do the ones that look like 3x squared plus 4x minus 1 divided by x plus 2. But we're going to do the same procedure. Okay? We're going to do it with polynomials. Okay? So, we don't need to do another number one, do we? Now, when we do this, okay, if there's an x squared under here, there needs to be an x and there needs to be a constant. Okay, we got our quadratic term, our linear term, our constant term. If I have an x squared and there's no x in the problem, you have to add 0x because an x will show up. So it just keeps everything lined up for you. Okay? If I had an x to the 4th in here, I need an x to the 3rd, an x to the 2nd, an x, and a constant. If something's missing, you put a 0x in there. It's always plus 0x or minus 0x, because if you're adding or subtracting 0, you're not changing it, right? You got to put 0x. Don't just add an x or an x squared or something like that. It's got to be 0x. That means it's really not there, right? Same thing out here. If you have an x squared out here, this was x squared plus 2, I'd have to write x squared plus 0x plus 2. Same reason, okay? So just make sure you remember that. Look for that. Now the division part is really easy, okay? All you worry about is the first term divided by the first term. Don't worry about that plus 2 there right now, on the division part. So all I'm thinking is 2x squared divided by, oops, not 2, divided by x. What's going to happen when I divide something by x? Yeah, I just subtract 1 from the exponent, right? You guys realize that, right? I mean, if you write it out long ways, I was going to cancel one of the x's out, right? Or subtract one of the x's. So, just like we did up here. How many times does 3 go into 4? We put a 1, right? How many times does x go into 2x squared? 2x times, right? And where did I put that 1? I put it up there, right? So I got to put this 2x up here. All right? If I just look at this one, 4 goes into 13 how many times? 3. What do I do with that 3 and the 4? I got to multiply, right? To get that 12. Well, what do I do with the 2x and the x? Multiply, which is 2x squared. But you also got to multiply 2x times the 2. That's where that 2 comes in now. What is 2x times 2? 4x, right? That goes under the 7x. What do we do with this 13 and 12 now? We subtract, right? Well, what am I going to do with the 2x squared plus 7x and the 2x squared plus 4x? Subtract. Same thing, same procedure. What's going to happen to the 2x squared? They're going to be gone, right? What is 7x minus 4x? 3x. So over here, when we subtracted and got 1, what was the next step? Bring down the 2, right? So what's the next step here? Bring down the 7. And then we start over. We're going to say, how many times does 4 go into 12, right? And the 3 goes up here. Now I'm going to, excuse me. Now I'm going to say, how many times does x go into 3x? Right? 3 times, right? 3x divided by x is 3, right? And it's positive 3x, so this is plus 3. Okay? What do I do with this 3 that I put up here? I multiply it by the 4, right? What am I going to do with this 3? Multiply it by those 2. So what's 3 times x? What's 3 times 2? What do we do? Subtract. Same procedure. Making sense? What's my remainder? 1. So then I write, since it's a positive 1, I write plus 1 over what? X plus 2. That's polynomial long division. Just like regular long division, but we got those x squares and x's and stuff. Yes? Yes, correct. Any questions? Not so bad, right? All right, so you guys go ahead and try that. Yes. Yeah, the x squared plus 5x minus 28 goes where? Under the division symbol, right? The x minus 3 goes out front, right?
I don't know where to start.
Always that. Divided by that. What do you worry about? So what's that?
Yeah.
Yes, correct. Right. It's always going to happen. Yes.
Probably should have wrote one down.
Now divide again. Yeah. Like that.
129. 8.
Right. Plus, right? Plus. Now the multiplication is that. And under there.
Don't even know what I'm doing. Go back.
You can help her.
I don't know what I'm doing.
8 times 3.
Is this it?
Just do it more. I watch it. I did that too, and I got 129. That's not right.
Right.
What do I do with that? I got you. See, I told you that's what I did.
I haven't done lots of them.
I haven't seen it yet. I ain't seen it
All
yet.
right.
It's just not the same.
Yes, it is. It is. Right. That's just set up for it. It's just, yeah, it's not set up.
Yeah.
Yeah, it's not set up.
That's right.
Oh, I switched mine, that's probably why I'm wrong.
Where'd you switch?
I put this one.
No, that's what
Wow. We went over that.
So those can't.
We literally did.
No. Well, we
We
go
averaged
minus.
that. Nope, nope, nope.
Yeah.
Okay, okay, okay. Yeah, I got it.
Hey, mine's Rick Coral.
This year. All right, you guys are doing good. All right, so do I need to add any zero x's in? No. All right, so x minus 3 is out here. And then the x squared plus 5x minus 28 is in there. Again, all you worry about is that divided by that, which is a really easy problem, right? It's just x, correct? So the x goes up there. Now I multiply x, it's like distributing. X times x and x times -3. And then we do subtraction, right? So that means those x squareds go away. That's what's supposed to happen. But what's going on here? Minus a -3. That's addition, right?
Yeah.
So that's where we make a mistake sometimes. Minus a negative is addition. So it's 5 plus 3, which is 8x. All right, bring down the minus 28. And then start over. What's 8x divided by x? 8, right? And since it's positive 8, it's plus 8. Okay? What's 8 times x? And 8 times -3? -24, right? When I subtract, what happens to the 8x's? Cancel. Again, I have a minus a -24. So I'm actually going to add 24, right? So what's -28 plus 24? -4. So there's my remainder. So when it's a minus, I just do minus 4 over x minus 3. If you want to put plus all the time for your remainder, that's okay. But what do I got to do to that 4 then? Make it negative, right? So either way is acceptable. So far, getting a little better? Okay. So let's look at this one. I'll just go through it. You guys talk me through it, okay? I have an x squared plus 2 here. So what do I have to do? What's missing? What's the order? What's after x squared usually? X and then the constant, right? So I got to put a plus 0x in. Then I have a 3x to the 4th. What's missing? An x squared, right? Anything else missing? An x also, right? So you have to add 2 zeros in this one. Make sure it goes down in order, because an x squared will show up in this problem, and so will an x. So we have to do that. Then everything lines up for you, all your like terms, okay? So again, though, I know there's lots of terms there, but all I worry about in my first division is that divided by that. So when we do that, you know, if you want to write it out like this, if this will help you, go ahead. 3x to the 4th means that, right? And x squared means that, right?
Yeah.
So if I do that, what's my answer?
3x squared.
3x to the 2nd. Does that make sense? Okay, if that helps you, go ahead and do that. Basically, all I'm doing is subtracting the exponents, right? All right. So 3x to the 2nd is up here. So what's 3x squared times x squared? Thank you guys. What's 3x squared times 0x? 0x to the third, right? What's 3x squared times 2? 6x squared. So there's an x squared that showed up. If I didn't have the 0x squared there, it'd just be a minus 1. Can I subtract 6x squared from a negative 1? No, they're not like terms. So the reason we do that, we just keep everything lined up nice for ourselves. Okay? So that's the important part. At this point, what do? Subtract. Those canceled. What's 2 minus 0? 2. What's 0 minus 6? Oops, that's not a squared. Sorry, that's cubed. That's a negative 6, right? And then bring down the next term. Now we start over. What's 2x cubed divided by x squared? 2x. Positive or negative? Positive, right? So it's plus 2x up here. What do I do with that 2x now? I gotta multiply to bring numbers down, right? So what's 2x times the x squared? 2x cubed. What's 2x times 0x? 0x squared. What's 2x times positive 2? 4x. Okay, now what? Subtract. Same procedure, right? Oops. So those go away. What's a negative 6 minus 0? Negative 6. What's 0 minus 4? Negative 4. And then bring down the minus 1. Okay? So, again, I went a little too high here. Oops, too low, I guess. What is negative 6x squared divided by x squared? It's negative 6, right? So I put minus 6. And then what do I do with that minus 6? I multiply it to get those numbers underneath, right? It's like distributing. Negative 6 times x squared. Negative 6 times 0. And negative 6 times 2. What do I do at this point? Cancel the 6x negative 6x squared because I'm subtracting, right? So what's negative 4 minus 0? Negative 4. X. And what's negative 1 minus negative 12? Positive 11. All right, so that's my remainder because I don't have any more numbers to bring down, right? So my answer then, I put negative 4x plus 11. And when you do this part, you don't have to put the 0x in. That'd save yourself some room. Okay? I think you guys are doing all right. It's just repetition, right? All right. Good job today. 4 problems. Not too bad. 2, 4, 6, 8. All right. Good job.
I made 2 there.